In 2026, 7 different nations achieved a mathematically perfect 100 out of 100 score for their water quality. This is the annual Environmental Performance Index. If you look at the top 10, countries like Germany, Switzerland, the UK, and Norway, it's easy to look at that tied score and assume their water systems are practically identical. A perfect score implies a standardized, uniform result. It suggests that turning on the tap in London is mechanically the same as turning on the tap in Geneva. But these nations reached the top of the list using 2 completely opposed strategies. Half of them hit the geographic lottery. The other half spend billions on brute force engineering. All 10 of these countries give you safe drinking water today. However, the specific methods they use dictate the hidden costs you pay as a resident and determine exactly how vulnerable your local tap is to a shifting climate. This chart plots the top-ranked nations by their access to natural water sources versus their reliance on engineering. Down here in the bottom left, we have Switzerland, Norway, Finland, and Canada. Switzerland pulls its municipal water straight from high-altitude alpine lakes and mountain springs. The surrounding rock acts as a massive natural filter. The water is so clean at the source that a substantial portion of it is pumped directly to homes with absolutely no chemical treatment required. Norway runs a similar playbook. They utilize deep glacial landscapes and mountainous terrain to naturally isolate their surface water supplies from urban contamination. Canada and Finland achieve the same result through sheer volume, drawing from thousands of inland lakes and vast freshwater reserves. Relying on these massive surface waters keeps municipal infrastructure costs incredibly low. Nature does the heavy lifting long before water enters a pipe. It is a highly efficient setup. But this entire model depends on the environment remaining static. If glaciers retreat or weather patterns shift, these low-tech systems are highly exposed. Going back to our chart, look at the top right. Germany, the UK, and Luxembourg lack that vast, untouched wilderness. They get their perfect score through strict regulations and heavy technology. Germany operates under the strict EU Water Framework Directive. They rely on groundwater, which demands massive, capital-intensive treatment plants to process safely. To guarantee purity, these facilities use a rigorous multi-step purification process. They deploy complex membrane filtration and active oxidation as barriers against contamination. The UK faces a similar hurdle. They pull from everyday surface rivers and reservoirs, sources that naturally carry a higher risk of agricultural and urban runoff. To hit that 100 out of 100 score, the UK hammers this water with aggressive active carbon filtering and ultraviolet treatment. Once the water is treated, distributing it across dense urban grids requires an extensive, actively managed network of pumps and towers. This approach proves you can manufacture perfect water anywhere, but doing so demands massive, constant energy consumption and high infrastructure upkeep, costs that are passed directly to citizens through utility bills and taxes. Then there is a third group sitting right in the middle of our chart, the hybrids. Greece, Italy, and Ireland combine local geological advantages with heavy technological support. Greece has to provide top-tier water across dozens of decentralized islands and dry coastal environments. They take advantage of natural limestone aquifers for filtration where they can, but in areas of absolute freshwater scarcity, they rely heavily on energy-intensive desalination plants to make up the difference. Italy uses a similar mixed model. They route relatively clean alpine mountain water down into heavily regulated urban networks, which lowers the overall chemical treatment required at the municipal level. Ireland pulls mostly from local rivers and lakes, but they have had to invest heavily in modernizing their older treatment plants to manage organic matter and microbial risks. The hybrid model works well to bridge difficult geographies, but relying on stopgaps like desalination or constant system upgrades still places a heavy financial weight on the local economy. If you are looking to relocate or trying to assess a country's long-term stability, a perfect score on a spreadsheet doesn't tell the whole story. You have to look at the specific trade-off that country made to get there. It is a choice between carrying a heavy financial burden or accepting environmental exposure. The engineering powerhouses guarantee safety regardless of the weather. But as a resident, you will pay for that certainty through perpetual infrastructure taxes and the massive energy grids required to run them. Conversely, relying on pristine alpine runoff keeps your current tax burden low and your water chemical-free. But that system is incredibly fragile if a warming climate disrupts those natural reserves. Evaluating a country's water quality requires choosing between two specific systemic risks: high taxes for industrial maintenance or high vulnerability to a warming climate. This matrix shows how those risks align with your personal priorities. If you want water that is naturally filtered and mostly chemical-free, you target the geographic lottery nations like Switzerland or Norway. But the hidden risk is you are buying into a system that only functions if the local climate remains stable. If you prioritize guaranteed infrastructure that delivers clean water regardless of the environment, you look for engineering powerhouses like Germany or the UK. The trade-off there is accepting highly processed water, along with the high taxes required to keep those massive treatment plants running day and night. A perfect score today is only as stable as the infrastructure behind it, whether that's a melting glacier or a synthetic filter filling your glass.